So I hope you received my email just about the recording, right? So you can always look into that page. So you got a slide, source code, and today I'm going to develop more JUnit example. But Matthew will be back next Monday. Yes, he will be back. Okay, so today I want to start with finishing up the JUnits. So let me just briefly recap what we have done. So this one important piece of the puzzle we have to solve. Because there are two kinds of JUnit tests you can write, and we only talk about one of them. So I would like to review the other one as well. The other one is a little bit tricky to actually write. Okay. Again, very quick recap. We talk about this small problem here. We got 3 attributes. So we talk about utility classes. So everything is static. We have 2 constants. We have maximum. We have the upper bound. We got a lower bound. And we also have a counter. Okay, that's what we have. And we know that there's only one requirement we have to satisfy, which is the counter must be in between the lower bound and the upper bound. Every time you try to change your counter value such that it will either go above the maximum or go below the minimum, you should really throw some input, some illegal argument exception, because it violates the preconditions. Okay? So now let's see that. So we got 2 possible cases, and we talked about that last time, and you can just encode them like this. We also talk about if you're given a certain precondition, you should really judge whether they are good enough or bad. You can refer back to the recording if you still got questions. Okay, and we talk about you got different cases that you can encode as a console tester, which means you simply just try to run the program and try to compare with your eyes how the output looks like in the console. If they kind of match your expectation, it's a pass. Otherwise, it's failure. As we agree, it's actually very, very tedious process, especially in realistic projects. You got a large number of scenarios you would like to test out, maybe close to 1,000 or maybe 1,000, more than 1,000. In that case, you don't just want to run your tests manually every time. What you really want to do is just automate the running. Click a button and it will tell you if anything failed or everything passed. Okay, so that's the and also we drew some state diagram last time to say to be sufficiently complete, so you need at least 8 cases for this small example, right? That's what we talked about last time. So later on, if you're given in the lab or maybe in the projects later or in the lab test, so we might just give you a problem there and ask you to come up with the sufficiently complete test cases. So that's kind of the thing you should really try to practice yourself. Okay. Okay, why do we need JUnits? We want to automate the testing of the correctness. Again, correctness is somehow relative. You cannot say, since I got a green bar from JUnits, so that means my software is correct. Because you can simply just run a method which does nothing in JUnit, as we saw last time. It will just give you a green bar. However, the best way you can do is try to really improve the quality of your tests. And as I said last time, you can draw some state diagram, or you can think about all the boundary cases, right? So these are the 2 most common strategies. But if you really want to learn a little more, you can feel free to read some testing, software testing book. Okay, so now let me just go through again. What does JUnit do? JUnit is simply just a normal class which is trying to use your software, and they are trying to use it in 2 different ways. Either they will try to use your software in a legal way, which means, for example, I try to increment the value of the counter from 1 to 2. After the increments, I would expect the counter value becomes 2. So I got some expected outcome, and I can want to see the actual outcome to see if they match. If they match, it's a success. Otherwise, it's a failure. The first category is very easy, but the second category is a little bit more tricky. It's slightly the flip side. So let's say I'm trying to decrement the counter value when it is already the minimum. In this case, I cannot expect any normal outcome because the counter value should never go below 0 and become -1. It should never ever do that. In that case, what would I expect? I would expect some illegal argument exception to be thrown in that case. So now you can see the test case will be considered as a success if some illegal argument exception is thrown. If no exception is thrown, it's considered as a failure, right? So it's kind of slightly different, okay? It's kind of the flip side of the idea. So that's kind of just conceptually, but I'm going to show you how you can verify that in JUnits. Okay, so we talk about this, so I just want to go directly to how you can write such cases, okay? Let's just go back to your Eclipse. Again, you can actually just download the source code and then import the projects. I assume you have done that already. So let's have a quick look. Over here, you have 3 packages. Again, we have implementation, which we have counter. And we have also tests over here. So you already have a test class called test counter. I'm going to create a new one just to start from scratch with you. Whenever you want to create a new JUnit test, right-click on the package and say new. Rather than class, you're going to say JUnit test case. Okay? Say that, give a name. Since I already used up the name test counter, I can say test counter 2. You don't need to worry about other text box, the check boxes over here. You don't have to, because they're kind of more advanced. It's not really covered in this course. But if you're really interested, feel free to Google and then try to see how they can be used. But for this course, the default option should be sufficient. Let's call it test counter 2, and then we can say finish. You can see what the JUnit class would do is it simply just import certain packages for you, especially the assert. So we're going to do assertions. Okay? You can see that by default, they simply give to you something called fail. So it's really important to know how you can fail trivially. I will also show you how you can pass trivially. You should really know both. Okay? So for this one here, I haven't touched anything yet. Why don't we try to run the JUnit test first? Go to Package Explorer. Okay, let's right-click on this test counter 2 and try to run it. So if you right-click on that, you can say run as JUnit test. That's what you got to do. So every time let's say inside your project, you might have more than one JUnit test classes, or you may have more than one classes which has the main method. You have to just right-click on the right one. Okay. So now here, right-click on this particular one we want to write. Let me go back. Right-click on that and go to run as JUnit test. Now what we got is a red bar. Whenever you see something red in JUnit test report, that means you failed at least one test cases, at least one, which means your software at the moment is not perfect according to your test cases. However, we can see that in some ways it's not fair because we simply just failed directly, right? So that's how you fail trivially. Okay? How can I pass the test case trivially? Let me just do that and then I'll define what does it mean for a test method to succeed. I simply just comment that out, which means it's not going to fail deliberately anymore. So what does this test method do? What would it do? Nothing. It simply just, you can see the only instruction that used to be there is now commented out. So it does nothing. Okay? Which means the test method would just execute without throwing any assertion failure, or it wouldn't throw any exception. Let's try this. Make sure you save the file. And then you can right-click on that class again. You can say run as JUnit test. If you now do that, green. Okay? You see, now we are trying to pass the test trivially. You can see the test case is not doing something very useful, but still pass. So what does it really mean for the JUnit test case to pass? Let me just write it down over here. And then once you get a principle, the 2 category of tests will be rather easy. Okay, so let me just go to my iPad notes. Okay, make sure you can see that. So what does it really mean for a JUnit test method to succeed? The principle is easy. So when does a test method, so when I say test method, I mean any method that comes with a test tag, right, as we said last time. Okay. When does a test method succeed? Okay, the principle is this. It will be that if no exceptions thrown and also no assertion failures, If both cases are the case, then that's considered as a success. Okay? Otherwise, if there was any exception, doesn't matter which one, if there's any exception that's thrown from the test method, or if there's any assertion failure, in that case, it's considered as a failure. Okay? I'll just say otherwise. Otherwise simply means some exception or assertion failure. Or assertion failure. In this case, it's considered as a failure. Okay? It's a simple principle. Okay? And now we have to somehow apply this simple principle to the two categories of tests. Okay? Let's go to the first category just to review. Yes?
Wouldn't you want your test to make sure that the exceptions throw when they should?
Exactly. So that's the second category which I'll get into. Just bear with me. Yeah, it's a very good question. So you can see that the principle is very easy, but let me just repeat the question again. It's a very good question. You might be wondering, if there's any exception thrown, it would be considered as a failure, but what if I'm expecting some exception to be thrown? For example, I'm trying to decrement the counter value from 0 to -1. In this case, I shouldn't be allowed to do that. In this case, I'm really expecting some illegal argument exception to be thrown, but it would be considered as a failure, which is not right. Okay? So we gotta really turn this around a little bit. Okay? I'll get there. Okay, let's just review the first category very quickly, and also there's a small issue I want to mention. You gotta be careful when you test the utility classes. Okay, I'm gonna go back over there, and then I'm going to add a new class, which I did already. Very good. Okay, this one is not very useful. Okay, let me just make a comments for you. First of all, this test which failed trivially. Okay, I'm going to give you the second one, in which case it does nothing. Now, if you apply the principle, now it makes sense. This will pass trivially. Right? Because you can see the first one simply just fell. So there was an assertion failure. In the second one, nothing happened. So that's a success. Okay? So you can feel free to uncomment this later, but for now, I'm just going to comment them out just to avoid distraction. Okay? So now, I would like to add the first test. The first test is, first category. I do expect something normal to happen. Okay? Let's say, first of all, let's declare the tag for the test over here, and then I'll say public void. Let's say test increments once. Okay? It's a very simple one. So what I want to do for this test method is, I want to start with the initial value, which is the minimum 0, and I will increment that once. So I'm expecting the value to become 1. That's what I want. Let's do that. Start with initial value of counter being the minimum, so I can say this. So I can say simply, I can make an assertion already. I can say assert true. So we kind of saw this last time briefly. So this is one of the assertions that's very commonly used. I'm just showing you this in the class, which means I'm asserting some Boolean expression which must be true in order for this assertion to pass. If it happens to be false, then there will be some assertion failure. Okay? So now, the initial value should be equal to the minimum. So I can say counter dot value equals counter dot minimum. Okay? That's a very easy one. Okay? I simply say the initial value should be the minimum. Let's do this first. Since I already ran it once, so it will be remembered. So if I say run it, okay, it's a green bar. It tells me that, yes, initial value was really 0. I can make it fail, just make sure it's really doing something sensible. If I simply say the initial value is 1, in that case, wow, it will be false, of course. Right? Just failed. I'm just trying to show you, how you can play with the test result. But the initial value, we know that it should be just 0, the minimum. Let's do a little bit more. You can have more than one assertions in your test method. You have as many as you like. Okay, so now let's do one more. I can say do some updates, counter dot increments, and then I can say assert true. Counter dot value equals, it will be just 1, right? From 0 to 1. Now, if I do that, true. You might be wondering so far, what's really the good thing about running the first category of tests? Now let's temporarily imagine, what if the counter increment was implemented incorrectly? What if, okay? Let me just change that temporarily, okay? And let's see, a good test should really catch problem if there are any problems. So let me just go back to the counter. So that's the supplier, okay? So now you can see that somehow the increments was implemented correctly, just plus equal 1. But what if the supplier make it wrong? Let's say it says plus equal 2. Apparently this implementation is wrong, right? And a good test should really catch that. Would it? Let's see. Let's predict. So now the implementation was wrong. It will go from 0 to 2. In this case, after this increment here, it will go from 0 to 2. And counter that value will be equal to 2. 2 equals 1, false. That means what we expect is different from what's actually happened, right? So that's not good. So in some way, the failure of this test is good because it tells us some problem for your implementation. Fix that, okay? Any question about this? So I'm kind of playing around with the code. So if you find it too fast, just let me know, okay? Okay, let's go back and change it back to the right implementation, okay? So now, I want to do one more test. And this will illustrate some problems, some issues you have to pay attention to for utility classes. Let's say I want to test increment twice. Let's say that, okay? Again, I'm going to make sure the initial value is the minimum, and then I'm going to increment twice. Counter the increments, so increment twice. So now the expected value there is no longer 1, it should be 2, right? You should go from 0 to 2, okay? Now, we want to see if this test method here will also pass. We used to get a green bar, but we're not so happy with it. It's just only one test, so that's why we added another one. Now, would this one pass or not? Anybody? Do you think that will pass? Just, how do you think? Yes. You think no?
Yeah.
Why not?
So you just set the increment value to the first, the large one.
Mean which one? You mean this method here? Are you talking about this one?
Yeah, well, you set the supplier, the implementation.
Oh, I see what you mean. So I already fixed that. Yeah, it's back to the right one. I just changed that temporarily. Yeah, but it's good to clarify. Okay, now would you change your answer? Do you think that will pass or fail? Should pass? Good. Yes.
Not going to pass because his first counter increment is still applied.
The first?
You counter incremented earlier.
You mean in the first test, right?
Yeah.
Wow, that's brilliant. Okay. So I will explain that in just a moment. I suppose most of you might think this test will actually pass, but let's see if that's really the case. It is. Yeah, so something to do with a static, really, because we up to now we talk about utility classes, so everything is static, right? So now let's see if that will pass or not. Yeah, I was actually puzzled by that yesterday in the other section, so that's why I want to do it a little more systematically today. Okay, let's try that. It failed, okay, but now don't be too terrified to actually go to the failure trace. It can give you some information about where it failed, okay? You will see that we have some assertion error over here, but you can see over here, there's a line, you can just double click. It will bring you back to where we got trouble, Okay? You can see somehow we got trouble here. Counter the minimum value. Does it make sense to you? Okay. Make sense? Or does it make sense? Why don't we, there's something I can also show you. Okay, let me just run it again and double check it's really that method that has trouble. And then I'm gonna show you something here. Twice and once. One thing you should notice, I see what you, okay, let's now pay attention to this. You can see we were trying to run this particular test counter 2. And then you can see the sequence of running the test. It's trying to run the twice and then the once. Right? Okay? So now, what did we do in the, okay, let me just do this. Let me illustrate that. So first of all, let me just say my point again. If you try to look at the JUnits over there, let me just run the right one. If you right click on this, and then you run a JUnit test, first thing to pay attention to, we have some assertion error, first of all. And then we know that it is actually in this test increment once, okay? That's this method. But now we want to understand why. If you go back to JUnit there, it tells you the order in which they run the test was first to run increment twice and then increment once. Okay, that's the order, somehow they chose it. Okay, so now let me just go back to the board and then I'll show you what's going on over there, why it failed. Okay, so now let's add a new page over here and let's see. Let me just get rid of that. Okay, let's add a new page. Add a page below. Okay, let me just make first of all, make a point. For utility classes, where everything is static, is static, the order in which you run the test method matters. It does matter. Okay, now remember when I showed you back in the JUnit panel over there, so the order in which we ran the test method was like this. We ran test increment twice first. This was run first. And then we ran test increment once. Okay, so that's the order. We ran this first, and then we ran this. Okay, so now somehow the one that's ran later failed. That's really puzzles us. Okay, let's see. Let me explain to you why. The idea is very simple. First of all, we have to think about how do we visualize a utility classes. So the fact that everything is static, that means there's only one copy of the variables and the methods, right? That's what static means. So I'm sure Matthew went over that kind of slides with you. So now, how do we visualizing a utility class? Okay, I'll put it here. Visualizing a utility class. Okay, so now in this case, we have a utility class called counter. And over there, we have three attributes. We have minimum, we have maximum, and we have the counter value, right? Minimum and maximum, they're always fixed. 0 and 3, okay? If they're always fixed. So now the value, we know that initially it is 0, okay? So far so good, that's the initial value. So now, let me use a color to distinguish. Let's say we start with green. When we first try to execute this method here, what it does, it is going to increment twice, which means it's going to go from 0 to 1 and 1 to 2. Agree? Okay? So this one here is going to increment 0 to 1, and then 1 to 2, which means it's going to 0 to 1 and 1 to 2. Okay, so far so good. That's what that method does. However, when you run a JUnit test, it's going to run one method after the other. So when you reach the next one, you are still talking about the same utility class, which has been changed for its counter value already from 0 to 2 from the previous method, right? So now what's going to happen is, if you try to do that, let me just use red. When you get to this point over here, the initial value for the counter is no longer 0 because it has been changed by all the previous method. And we have this kind of interesting phenomenon simply because it's a utility class. Everything is static. There's only one copy there, okay? Wait a moment. And then, so now over here, the starting value of counter is no longer 0. It somehow has been accumulated, okay? It's actually going to be 2. And the 2 correspond to the 2 over here. So that's why when we were trying to do the assertion in test increment once, remember in the very beginning that we were trying to do this. In the very beginning of testing increment once over there, let me just go back there. If you go to that method there, we try to assert that the value is actually 0, but it's not because it has been changed by the previous test method. It's no longer 0. First of all, let's understand this is what's going on there. Of course, we got to fix it because having some initial value that depends on the previous test method, that's not a very good practice. You somehow want to reset the value for all the static attributes. So that's the solution. Questions? For that one, I'm not sure if that's really alphabetical order or some order that has been chosen. You know what? I tell you what, it doesn't matter. Even if the test increment once was ran first, you're still going to have the assertion failure for the second one, right?
Why does it choose the order in which the test?
For that one, I'm not sure, but I don't think the order really matters because after all, it's going to run all the tests. The order in which it is run is not really our concern.
Like want to see like what happens. You want to like add something to some order of your code. Then how do you choose like?
You know what? If you really want a particular order of testing your code, you better group them in the same test method. Otherwise, if you simply just separate them out into different methods, each method is supposed to be starting with a fresh value of your objects and then build something up. Rather than saying you're depending on the order of the methods being tested, that's not very reliable. Because let's say JUnit happens to choose the testing the method in this particular order today. They might change it in the next version.
Like if you're like in development, then like you bring your code to like your code system developing like one stage to another. So it would be good if you could order like the tests.
Yeah, again, as I said, the order of the test shouldn't matter because each test is supposed to be independent. You shouldn't really try to depend the order of your testing, right? Okay, so that's about what the issues are because somehow whatever that ran before is going to accumulate the value for the static attributes. So how do we fix it? So the very simple fix is we can simply say every time, since we're dealing with the static attributes, we can simply reset those values back to the minimum every time we do it. And to make sure we really start with a fresh copy. Okay? So it doesn't really matter how the JUnit is going to run our test anymore. Okay, so now let me fix that. So first of all, let me write this comment here. Since we are testing a utility class, there is only one copy of the attributes and methods. This means the starting value of counter of a test method is no longer guaranteed. To be the minimum. Instead, it will be the accumulated value from the previous test method run. Okay, that's kind of the idea. Okay, I'll just write it down so you can, when you download the source code from today, you can see that. Okay, so now how do we fix? The fix is simple. Fix is reset explicitly all the attributes to their initial value. In this case, we want to reset the counter back to its minimum. Okay? So now we want to do for every method, because we don't want to rely on how what's going to be the order that JUnit is going to run our test. Okay, so what we will do is reset. You can say counter dot value is assigned to 1. Counter is value is assigned to 1, which is reset. Sorry, not 1, 0. Thank you. You know what? So that's why always when you there's another software engineering principle. You should try to avoid using so-called magic numbers in your code. In this case, 0 is not perfect either. What I should have said is counter dot minimum, right? That's a little bit more informative to me. Okay. Just an aside. You might be thinking that, well, this one is not very good because I'm going to repeat the same line for every method, right? I'm pretty sure you got the same concern. So there, I believe there's a method in JUnit called setup, which you can define. But it's not really covered in this course, so you can feel free to experiment with that. What a setup would do is if you expect some certain block of code to be run in the beginning of every test method, you can put it simply into a single place called setup. Similarly, if for every test method at the end, you want to include a block of code, there's something called maybe tier off, something like that. So setup and tier off. Tier down was tier off, I kind of forget. Okay, so now let's run the test again and see if that will pass. Now I can say run as JUnit test. Now everything passed. Okay, yes?
We did reset the value of the counter, right?
We did. Before we didn't. Yes, you're right.
Why do we need to assert the counter value is actually minimum if we just reset it?
Oh, I see what you mean. So, you're right. Remember the reason that we found a previous issue was because we were trying to assert that the counter value is really the initial value. That's how we found the previous issue. And now that we're going to reset it, you're right, we can just remove the assertion if you want to. But of course, it's guaranteed to be true anyway, right? But it's always to have some extra level of guarantee. Yeah, good question. Okay, so that's about the first category of test. Now, I would like to talk about the second category. That one is a little bit more tricky. Okay, let's do that. Now, we want to test. We want to test an abnormal scenario. The counter value, say the current counter value is the minimum. And we try to decrement it. There's a possible scenario, so we want to test it. So now, the expected behavior of the counter program is to throw an illegal argument exception. Okay? That's kind of the expected behavior. However, remember what I said before. If you simply just allow the method, like a decrement, to throw the illegal argument exception, that is going to cause your test method to fail. Because remember the principle I just mentioned. Okay, let me just go back there very quickly, because the principle is really important. The principle I said before is it will only be considered as a success if no exception and no assertion failure. Okay? But if you simply allow the method to really throw the exception, illegal argument exception there, even if it is expected, it will still be considered as a failure by the test method. Okay? So somehow we want to say, if an exception is thrown as expected, maybe we can catch that and then do something about it. Okay? That's kind of the idea. Okay? Let me sketch the idea on the notes first, and then I'll write it down. Okay? Okay, so now let's try this. Import, sorry, not import. Add a page below over here. Okay, let's now do this method here. So now let's say test for abnormal scenario. Okay, that's what we want to do. So we define the test method here. Let's say void, and let's say test decrements from 0. Okay, like that. So now let's try this. Let's not worry about the initial value, but we do have to reset it first. So you would say counter dot value is set to be, I'll just say minimum here. Okay, to reset it first, and then we'll try the decrements. You would say counter dot decrements. Okay, just that. Very easy test. Let's think about what do we expect. So what we expect is expect illegal argument exception thrown from this line. That's what we expect. Okay? Let's just try this quickly in Eclipse, and you will see that simply writing this is not going to work. Let's see. Let's go back there, and then let's try that. So I'm going to say add test. Public void test decrements from 0. In this case, let's say counter dot value is assigned to its very initial value. Okay, and then we try to do the decrements. Counter dot decrements. Okay, just that. We do expect illegal argument exception to be thrown from line 58. Let's see if that will really be thrown. Oh, sorry, wrong one. Let me do it again. I did say minimum, right? Okay, good. Okay, let's try that. Right click, and then run as JUnit test. Why would that be there? Okay, let me see. Am I doing something? Let me see, counter here. So we have increment decrements. Ah, okay, we do have the precondition, sorry. This code was actually from yesterday. I just commented out, okay? So it should be there. Sorry about that. Okay, so decrement method is here. It tells me that if the value is already the minimum value, it shouldn't go below. So that's why you would throw the illegal argument exception. Okay, sorry about that. Okay, it's there. It should be there. Now let's go back to test counter 2. Let's run it again. Okay, right click on that, and then run as JUnit test. Now we do have some failure of the test, which means either some assertion failure occurred or some exception has been thrown. Okay. Now, if you look at that, it tells you some illegal argument exception was thrown from here, which is decrement over here, right? And also, if you go by the JUnit, if you go a little bit down, it can tell you that it's actually from this particular method. You can see, so far, it seems like it makes sense to us. You try to decrement when the counter value is the minimum, and then it really throws the illegal argument exception. However, the test method is considered as a failure, right? So we've got some conflicting interests over here, because test method can never accept any exception or assertion failure, but now we do have one, even though that's expected. So now, what do? We gotta somehow wrap around the code in some try and catch block and do something interesting to it, okay? But first of all, we gotta understand, if you simply just put 2 two lines of method, 2 lines of Java code over there, it's not going to work, even though the exception was expected. Okay, let's now go back to the iPad notes, and then let me sketch the idea to you, and then we'll put it back in Eclipse. Okay, we're going to add something to it. So now let's try this. So I'm going to say try over here, and we have catch. Illegal argument exception, some exception here, and then we have that, okay? Like that. However, if we simply do this, is it going to work though, right? Okay, I'm going to show you a version so this is not the right version yet. Let's justify why it is not correct, okay? I'll show it to you. So now let's see this, okay? Just remember that we simply just add a try and catch, which means imagine that if the illegal argument exception is thrown from this line here, it's going to be caught over here, right? Let's say, what if, let's imagine another hypothetical scenario. What if the decrement was implemented wrongly and there was no illegal argument exception thrown? What if there's no? In which case, we wouldn't go to the catch block. We'll simply go to the next line, right? It's a different path. If we simply go to the next line, and will anything happen? Nothing will happen. If nothing happens, it will also be a pass. You can see the test case over here also is not good. Okay, let me illustrate to you. First of all, let's go back there, and then, first of all, let's test this. Try, and then we'll say catch. Illegal argument exception here, just that. Only this, only adding the try and catch. I'm claiming that this is not good enough. Okay, I will show you why. First of all, we are trying to say if decrement throws the illegal argument exception, it will be caught over here, in which case we'll just do nothing because it was expected. This case is fine. Okay, let's verify that it is really fine. Again, let's run this again. And then you can say run as JUnit test. In this case, it's going to give you green. That's fine, because somehow the exception was caught, so nothing happened. Okay. However, this test is not good. Why? Let's keep this over here. Let me go back to the counter. Let me make some deliberate mistake in the supplier side. Now, let's say the decrement is very bad. It never complains. I simply comment out the part that throws the exception. That's what I do. Just that. Okay, you can see it will just decrement every time. Okay, now so it will just decrement. Now if I go back to test counter 2, you can see that over here, what's going to happen in this line here? No exception will be thrown. No, right? Because it will simply just decrement from 0 to -1. And it will simply just go to the next line and then nothing else to execute and terminate the method. Again, this method, since there's no exception and there is no assertion failure, so it's going to be a success. Okay, let's verify that. If you right click on that, you can say run as and JUnit test. You see, it's also green. You got 2 greens for both the okay and not okay scenarios, which is not good. Okay? You see, a good test should really give you a red bar when you got something wrong. It should really give you a green bar when nothing goes wrong. But somehow this test over there, with only try and catch, give you green bar for both cases. So that's not good. Okay? I'm running a little bit fast over here, but please rewatch the recording. I think basically that's kind of the flow. Now, how do we fix it further? Okay? We want to make sure for the good case where the exception is thrown, the expected exception is thrown, then we should let it green. In the case where the expected exception is not thrown, we have to give it red. That's what we want to do. Okay? So let me just go back to the iPad notes and let's see how we can fix that. I'm going to highlight 2 places for you, and that's where we should do. We'll do some trick. over here. This is one place. This is the other place. One place is immediately after decrements. The other place is inside the cache. What should we do? Okay, we have to be clear about how can we reach these two places. The first yellow highlight over there, if we can reach that line, what does that mean? That means no exception was thrown. That's why we can get there. The second yellow highlight over there, what does it mean when we reach there? That means some exception has been thrown from the decrement method. That's why we get to the catch plot, the part, right? So we got two places there. So now, we know that, let's talk about the one below, that's a little bit easier. In this case, that means illegal argument exception thrown is expected. And in this case, just do nothing. Like that. Okay? On the other hand, the one above, let's say over here. In this point over here, the illegal argument exception was not thrown. In this case, we should fail because you're expecting something, right? In this case, what we'll do is remember the fail that we had before. You can say fail. You can say illegal argument exception not thrown, something like that. Okay? So that's a complete story. Okay? So that's why I said the second category of test is a little bit tricky. You can see we started with no try and catch, and the second version, the intermediate version, was we got only try and catch. Also not good. So that's the final version, where we got try and catch and also one fail statement in the right place. Okay? You should really try to understand the complete story. Otherwise, just don't memorize. If you memorize it, it's not going to work. Okay? Let's fix that in Eclipse and let's double check. It will give green to green, red to red. Okay, now over here, illegal argument exception, the expected illegal argument exception not thrown. Fail. In this case, I'll say fail. The expected illegal argument exception was not thrown. That's one way. And this place over here, we'll say the expected illegal argument exception was thrown. Do nothing, which means it's a success. Okay, that's kind of the trick. Okay, let's try that. Remember the implementation for counter. Let's start with the wrong one first. In this case, it should give us a red because the illegal argument exception wouldn't be thrown, right? If you try that, it's going to, let's see, run as JUnit test, right, red bar. It does tell you that you were expecting some illegal argument exception, but it was not thrown. That's good. Let's try the other case. Let's say now the supplier fixes their code over here. Let me just go back to counter over here, and then I'm going to uncomment these. So that would be the correct version. Okay. Oops. Sorry. Let me just do the, somehow it doesn't work, the shortcut, so I'm going to do it the naive way. Just bear with me. Okay, so that's the correct version, where the supplier does check for the precondition violation. Okay, let's now try that. So now it should give me a green bar. Run as JUnit test. Okay, it's a green. You can see red and green. Rather than the intermediate version for both cases, it just simply gave you green, which is not good. Okay. Okay, any question about this?
You know, like when you have like illegal argument exception, and you got the after that, what does the do for the system?
So, okay. So the question was, let me just go back to try and catch over there. So it could be a little bit of review. So the question was, when I say catch over here, you can see I'm trying to catch an instance of illegal argument exception over here. So the question was, what's this E to do? Okay? So basically what we are trying to do is, in this case, I'm not trying to make use of E. I'm not trying to. But if you really want to make use of the illegal argument exception being thrown, you can actually refer to it. So this, you just name it. So this is like a name, just declare. So for example, I can say system.out.println. I can say e.print stack trace, right? That's one way to use it. I'm just saying, so whenever you got some exception objects that's being caught by the catch block, in which case you can do some further work with it. Yep. Go ahead.
So like basically it's an object which you can refer to, and inside that object you have like when you put the action flag where the where you call that error or
Yeah, so exactly. So basically, E is simply how you name the exception object that's being thrown. So you can make use of it. That's one possible use. Okay. No system out of print line, I forgot. Okay. Just like that. That's one way to use it. To say if you really got something there, you may want to print out an error message. But in this case, we better not, because we simply just want to do nothing. Okay. I'm just saying, give you one example. I don't want to confuse you the rest, so I'll just get rid of it. Okay. Okay. Any questions? It doesn't really matter the name, as long as it doesn't really matter. No, it can be the same. The E is only within the scope of that particular block. Well, it's up to you. It's completely up to you. Yeah. No. For example, let's say here, if I say catch, for example, I'll just say null pointer exception, for example. If I also put E over here. So the compiler would not be confused, because over here, if I say E over here, that really talks about this particular illegal argument exception. If I use E over here, it's talking about this null pointer exception. So we have a particular scope, so you don't have to worry about the name. If you have the same name, that's fine, or you can have different name.
But the thing is, if you use in your cache, you use like illegal exception, and if you use like Boolean operators on different illegal exceptions.
No, you cannot apply Boolean operators on exceptions.
When you try to catch them, like you cannot, or something you don't.
No, you cannot. No. I'm afraid you cannot. Okay, any questions? Do you have a questions? Or go ahead.
If an exception is caught and runs the code aside, is it going to continue? Can you put more stuff after the catches?
You definitely can. So I'm kind of trying to show you the simplest pattern you might have. So for this course, we didn't really teach you too difficult stuff in terms of precondition violation. We just say illegal argument exception. Let's say if you want to do a little bit more sophisticated, do it in a more sophisticated way, in which case you have to create your own exception classes. You might say amount to large exception, amount to small exception, right? And then you can have several catch block over there. But that's something you don't need to worry for this course, yeah. Okay. But the basic idea, hopefully that's clear. You know, you got some precondition violation there, and then you want to make sure you got a try and catch, and also the fail statement there is really crucial. So for example, one good test question could be either lab test or final exam. Let's say I give you this test, JUnit test over there. I might just leave out this line here. I would say, is this test appropriate for testing if the precondition violation is going to be thrown? And the answer, of course, should be no. And you should justify, right? So that's the one idea about final exam questions. Yeah. Sorry? No problem. That's no problem. Any questions, guys? Anyone? Okay. If no questions, I'll just go on. Okay. One question here. Have you guys used debugger and breakpoints in JUnits? Not in JUnit, in Eclipse. Maybe, yeah, let me just write it down. If you haven't, I think it will be useful to you. Because what Matthew really want me to do is to finish JUnits and cover some object stuff. But I think for breakpoints and debugger, it could be quite useful to you. So let me just write down the term first. Okay, something called this, breakpoints and debugger. Have you used that before? In Eclipse. Breakpoints and debugger. No? Okay, how about I show you that very quickly. I think it's worth showing. I can spend about maybe, hopefully within 10 minutes to give you some idea. You can feel free to watch the recording and try to practice yourself. So it's a very nice tool when you're, let's say you're trying to do your labs, you're trying to do your lab test, somehow your method doesn't return the right value. Nobody's around you to help you. You can only help yourself. Rather than staring at the code with your eyes, you better rely on the breakpoints and debugger. I'll give you some idea, okay? The idea is very simple. The principle is we are trying to put your program execution in slow motion, the idea. Put program execution in slow motion. So you can examine variables. Examine variables in the intermediate steps. Okay, I'm going to use that second category of JUnit test to actually show you. Okay, I'm going to show you how you can do that. The idea is very simple. Okay, I can move that a little bit up. Yeah, like that. Okay, let's see how you can put the program into slow motion. How do you do that? Let's just go back to Eclipse, and then let's say we have this test method here. Okay, let's say this. Let's go back. First of all, let's go to counter. Again, let me try to do my old trick again. I would like to put this place over here to be in comments. I'll put that into comments over here. So this one here, sorry about that, that's too much. Okay, so this method here, again, it doesn't throw any precondition exception. It simply just does a minus minus. We know that it is bad, okay? Again, if you run the JUnit test, it's going to give you a red bar. Let me show you that first, and then I'll show you how you can use breakpoint. Let's say you are now in the lab test, and you try to do this. You say run as JUnit test. You see a red bar, okay? So now how can you fix it? Let's say looking at the code with your eye is not an option, because sometimes when you're too much into it, you got too much biased. You thought you just correct. So now what should we do? First of all, let's find out which method is causing the problem. You can see that we had some assertion error over here, and then you can simply double click on this line here. It tells you there's something wrong with this test method here, something wrong. You're not too sure why it is wrong. What we can do is we can put a breakpoint in the beginning of the method. You can see there's a blue panel over here, blue bar over here, right? You can click on any points. So for example, if I click on here, it gave me, it was put in line number 58. What does that mean? That means now I can ask Java compiler or Eclipse to run in the debugging mode for me, which means when it reaches line number 58, before it tries to execute that line of code, it's going to pause over there and wait for my instructions. Okay? So the good thing about it is, if I can execute the code line by line, in the beginning of each line, I can see, okay, in this line here, the counter value is 0, for example. And after this line, I would expect the value to become maybe 5 or maybe 3. If it doesn't really happen, that means there's something wrong with this line. So we are really trying to pinpoint where it really goes wrong in our code. Okay, I will show you. Let me show you. So I put a breakpoint over here. So you can put a breakpoint anywhere you like. So anywhere that you think that's suspicious, there might be something wrong, you should put it there. Okay. Since we know that something wrong with this method, but we are not sure where, so we simply put it in the beginning. Okay. So it's 58. Okay. If you want to cancel some breakpoint, just double click it again. It's gone. Okay. Let me put it back. So now, how do we debug? You can see there's a bug button here, right? That's debug. So you can, if you move your mouse over, it tells you it's going to debug task counter 2. Yes, we want to do that. If you do that, let's see what's going to happen. For the first time, it's going to ask you if you want to change the perspective. So basically, in the Eclipse, there are at least 2 perspectives. One is a Java, which means you're trying to edit your program and execute it. Another perspective is called debugging perspective. You can switch back and forth. So now, since we are debugging, we can switch to the debugging perspective. Let's just say yes. Okay, you can see there's a green line, green highlight over here. It tells us now we are at this point over here, right before we try to execute this line over here. Okay? Okay, let me just do that. Okay? Tell me something. If I try to execute this line here, what's going to be the effects? Because I'm trying to set the counter the value to counter the minimum counter value. So that should be 0. And there's something I would like to bring your attention to. So there is something called expressions over here, which means you can put whatever expression that will make sense in this context over here and check their value. Let me just get rid of the old one from yesterday, and then I will put some new one for you. Let me get rid of all of them. Okay, let me add a new expression in just a moment. So we predict after executing this line, the counter value should become 1. Oh, sorry, 0. Beg your pardon, 0. That's assigned to the minimum. So so you got several options here. You can say either step over here. Step over means I want to go to the next line directly. Or I got something called step into. Step into will be used if you want to walk into a particular method. I'll show you that. Let's say we simply say step over. If you do that, so now we are here. So now what do we expect the value to be? Well, let's try. You can say counter dot value. It tells you it's 0. That makes sense. That's immediately after we assign that to the minimum, which is 0. Now, so now we want to know what's going to happen for decrements. We know the counter value is currently 0, and we are trying to decrement. It should throw some exception. That's what we think, right? So now we want to see if decrement really does that. So we can step into it. If you step into it, sorry, I clicked the wrong one. Let me do it again. Okay, I said step over, now step into. Okay, we're here. And now if we say step over, now we're in this line. Now I should say step into. Okay, if I say step into, I'm now in the context of this decrement method. It's simply just decrement the value over here. It's going to decrement from 0 to -1. If you see that, this becomes -1. Okay, you can see so far, we can see that the behavior is not as expected. If you want to go from 0 to -1, there should have been some precondition violation. So if you say step again, so now you can see that we can now reach line 62. So now you can see a little more clearly why I said that should be a failure. If you can reach line number 62, that means from the counter.decrement, there was no illegal argument exception thrown. And that was expected, right? But it was not the case. So now you can see it's right before we try to execute this line. If you do that, you can see it's gonna fail. Okay? So if you just keep going, then it's gonna fail. You're gonna see some red bar over here. Okay? Let's do another case just to show you one more. Let me go back to Java over here. Let me just change the counter again. Let me just put this back. Again, let me do the naive way. I kind of forget what the shortcut is. So now this is kind of is the correct behavior. Let's try again using debugger. Let's go back to task counter 2. And remember we got the breakpoint over here. Let's try to debug again. If you try that, and let's say yes. Okay, over here. So now we are in a similar situation here. So now if you say step over, so now we are here. The counter value has been reset to 0. That one so far so good. Now we want to walk into it again. You can say if we say step into over here, so now you can see it's a different implementation here, right? So now let's try something here. You can see the value that we are trying, the value currently is 0, and the minimum value is also 0. You can also try that as an expression. For example, I can just copy and paste this line here. That's also 0. So 0 equals 0. True. If I say step over, so you can see it's going to throw the exception. Okay? So now it's going to throw it. And what's going to happen if the exception is thrown? That means in the test method, the catch block is going to catch it. Right? So now if you step over again, you can see now we are in the catch block. So it's a different behavior. So we are not in this line anymore because the expected illegal argument exception was thrown. Okay? So now we're here, and then we can simply just go to do nothing, and that will be a success. Okay. That's about breakpoints in debugger. I'm just showing you one small example. My point is, for breakpoints in debugger, it takes some practice. So if you really got some trouble with your lab submissions or later on any Java code, debugger is really your friend, okay? Because typically you know your code the best. If you simply ask somebody else to check your code, they have to spend more time on looking at your code. Why don't you just debug yourself, right? That's kind of my suggestion, okay? Okay, so now, any questions about JUnits and debugger? No? Okay. Okay, guys, I got two options for you. Okay, just don't tell Matthew. Okay, either we can finish earlier since I already finished JUnits, or I can just run another 10 minutes to teach you a little bit about object orientation. Option A, we are done. Option B, we will spend maybe 10 more minutes on object orientation. A or B? B? Oh, really? Wow, thank you. Wow, that's good. Wow. I'm surprised. Too surprised. Okay, I would like to just give you some very brief idea about object orientation. I'm just going to use my own slides, so you can also look at the relevant part in Matthew's slide as well. Okay, I'll give you some big ideas, and then we can talk about it. Matthew will talk more about it. So since this is my last lecture with you, I'll try not to follow the slides too closely. I'll just give you some idea, something you can think about. Okay, let me just show you one diagram, which I think that's the most crucial point to keep in mind, and then I'll show you an example. Okay, so I think let me just go to the diagram there. The one in the slide is a little bit too small. Okay, so that's the diagram I would like to show you guys over here. So this is basically what object orientation is about. Let's start with this. Okay, just focus on this part, real-world entities. So basically, why do we use Java? Why do we not use C? It's because the one advantage is Java supports something called object orientation. What's really good about object orientation? Think about what you're trying to do. You're trying to solve some real-world problems. So what are the problems in the real world? Is to deal with people or entities. For example, let's say the entity you might have, maybe a person called Jim, a person called Jonathan, or maybe entities would be maybe the points on a two-dimensional space, right? It can be 2 or 3, -1, -2, different kind of entities. And you can see we got different kinds of entities. So this might be the different kinds of problem you want to solve. So once you identify the problems that you want to solve, you can somehow translate them into Java. Okay? First of all, we understand always you want to solve the real world problems, but somehow you can translate them into Java. But how do we do that? Let's say we got two kinds of problem you have. Either you got a problem about persons, or you got a problem about points. Okay? So now, first of all, there in Java, what you define is you can define a class called person. And then I say every person has certain attributes. Every person has a name, has a weight, has a height. Every person has those attributes. And I also have a class called points. Every point has an X, has a Y. right? So these different kinds of entities. So now what's going to happen is, interestingly, once you try to execute your Java code at the runtime, you say, oh, I have one person called Jim, because he's a person, so he has a name, weight, and height. I got another person called Jonathan. He's also a person, so he also has a name, he also has a weight, he also has a height. But every person can be different, right? So although they both have names, but the name value does not have to be the same, just like every one of us, okay? So now, if you look at what's really happening at the runtime, what's really happening is, you can see the way we have the object structured with attribute values, they correspond very closely to our very initial attempt, which is to model the real world problems, right? So that's kind of the rationale behind why we are doing object orientation. Okay, so now I'm going to spend about 10 minutes. Don't follow the slide too much, but I want to give you some sketch on the notes, just to give you an overview of the tricky things about object orientation. Okay. So let me just open my iPad notes. I'm going to do that from now on until the end. Okay, now let me just get it. Okay, good. So now let me add a new page. First of all, let's understand the difference between class and objects. Okay, I'm gonna maximize that. Okay, set. So what's class versus objects? Class versus objects. You can think about class as a template, and objects are simply instances of the template. Let me give you one example here. Let's just use two-dimensional points. So now let's say a class can be, let's say a class point. Over here, let's say integer x, integer y. So this is a template. This simply means every point instance must have x and y. Every one of them. Let's try to see some example here. Let's say we have another class over here which is trying to use the point class. Let's say I would say class, let's say point application, like that. And somewhere I have a main method over here, like that. Okay, so now we are trying to make use of the class that we just defined. So we're going to create instances. Okay, let's try that. I'm going to visualize to you in just a moment. So over here, I'm going to say, so this is how you create objects in Java. You can say points, the class name, and also I can say P1 is assigned to new point. Let's say I simply just pass maybe 2 and 3. And also I got another one here, P2, new point. Let's say 3 and 4, like that. I got 2-point instances, okay, 2. Let's now understand very clearly what each line does. Okay, I'm going to add a separate page, and then I'll come back. What does it really mean when you have a line like this? Okay, so let's say I have points P1 is assigned to new, and then I have points 3 and 4. Okay, let's understand this very clearly. Okay, so the way I understand this is I understand that in 3 steps. So that would be step number 1. And then this will be step number 2. And this will be step number 3. Okay, that's how I understand it. First of all, step number 1. We are trying to declare something. Declare a variable A
variable P1. Whenever you're declaring a variable, you got to store something. But what do we store in P1? Right? So now it's a little bit tricky here. What does P1 store? I'm going to write it to you. So P1 can store the address of some person objects. Okay, so the address over here is really the point, address. It doesn't store the object entirely, it only stores the address. Okay, I will draw a diagram to you in just a moment. That's step number one. And step number two. Okay, step number two, we are trying to allocate space in memory and creates a point with x being 3 and y being 4. That's what step number 2 does. Okay, let me draw some diagram very quickly. Let's say for step number 1. For step number 1 there, I simply say P1 is a little bit like a pointer. Whenever you declare some variable which will store address, we call it a pointer. Okay, you will learn about pointer in 2031. Okay, so P1 is simply just a pointer. What about number 2? For number 2 over there, you can imagine that if this is the memory. Okay, so starting from some address, we're going to allocate some information for P1 for this point. Let's say we have x being 3 and y being 4. Let's say the starting address over here is just some binary address, right? I'm just making that up. It can be 00111, for example. Okay. So basically, what we have done over here is there is a separate region in the memory that we allocate for this particular new objects. The starting address is simply 00111. Okay. Now, what's really, but you can see the pointer P1 and the object in the memory, they have no connection so far, not yet. So what's really important is this line over here. It's assignment. So what number 3 does is store the address of the new point objects in P1. Yeah, P1. Yeah, it's P1. Good. So what does it mean? Number 3 is we are trying to store 00111 in P1 over here. But visually speaking, it's really like we are making P1 to point to this particular region, right? So that's what number 3 does. So we got 3 steps. Declare some variable which can store address only. Create a new object in the memory and store the address of the objects into that variable. That's what it does. Okay. Okay. I'll just give me a few more minutes. Okay. Having this in mind, I want to show you something in particularly interesting. Okay. Okay. So now, and that'll be last small topic. Okay. So now let's say we have point P1 is assigned to new point, let's say 2 and 3. And then I say point P2 is assigned to P1. Okay? You will see this a lot actually. So what's happening over here is, let's say for over here, we are trying to create, to say P1 is going to point to a new object over here of type points. You got 2, x and y, and 2 and 3. Okay? Guys? Not yet, please. Almost done. Not yet, not yet. And then what about P2 is assigned to P1? Since we are trying to do an assignment, so we are trying to copy the address over here into this variable over here. Okay? So what we do is letting P2 also point to this object over here. Okay? One more thing. It's called aliasing. Okay? And I will let Matthew take care of you guys from Monday.
All right, thank you. Yeah.